Welcome to educator.com. This lesson is about properties of numbers. In this lesson, you will learn to recognize and use the properties of numbers. Applications are to add and multiply numbers easily and to do mental math. Let's look at the vocabulary, which reflects the properties. Commutative properties. There are two, the addition property and the multiplication property. The addition tells us that a plus b is the same as b plus a. For example, if you did 2 plus 3, that is the same as 3 plus 2. Either way, 5 equals 5. So notice that in addition, the order doesn't matter. And with multiplication, a times b equals b times a. So if you were going to do 2 times 3, that's the same as 3 times 2. 2 times 3 is 6, and 3 times 2 is 6. Notice that there is no commutative property of subtraction and division because the order will make a difference in subtraction and division. In subtraction, if you did 3 minus 2, that would equal 1. But if you flip the order and did 2 minus 3, that would equal negative 1. So it would not be the same value. So you cannot switch the order. There is no commutative property of subtraction. And same goes with division. If you did 10 divided by 2, you would have 5, but if you did 2 divided by 10, you would have 1/5. So notice once again here, you would not get the same answer for division. So order does matter for subtraction and division, but the commutative properties of addition and multiplication tell us that we have the freedom to switch the numbers around. There are also associative properties of addition and multiplication. The associative property tells us that if you have grouping symbols, you can group together the first two, a plus b, and then add c, and that will give you the same answer as adding first b plus c and then adding a. And same with multiplication. You can multiply a times b first and then multiply with c, and multiply b times c first and then multiply with a, and you'll get the same answer. Notice that different from commutative property, the order of the variables or the numbers is not changing. I still have A, B, C on both sides, but what is changing is the grouping symbols. And an easy way maybe you could remember the words commutative and associative is, if a person is commuting, they are changing places. A person's daily commute may be their drive to work. So commute means changing places. And you'll notice in the commutative property, the variables or the numbers are actually changing their location. In associative property, you might think someone could ask you, who do you associate with? And that might mean who do you hang out with or who do you group yourself with? And in the associative property, the grouping symbols play the big part. Lastly, we have the identity properties of addition and multiplication. And unlike for commutative and associative, the identity properties are a little bit different for addition and multiplication. In addition, a plus 0 will give you back the same value a. However, in multiplication, it's a times 1 will give you the same value back a. Make sure that in multiplication you don't do a times 0 because that won't give you a back, that'll give you 0. So you want to be careful that for addition, it's adding 0 will give you the same value back, and multiplying with 1 will give you the same value back. And you can also think of the identity property being, if someone asked you for your identification, it would reflect information about yourself. So the identity problem is about getting the same value back. Let's see if we can recognize some properties. Which property is illustrated? So I have 2 plus p grouped together, then plus 6. And over here I have p plus 6 grouped together, and then you would add 2. But the order is the same, 2p6, 2p6. What's different here is the grouping. First 2 plus p was grouped, then p plus 6 was grouped. So this is the associative, be careful with your spelling, associative property of addition. And you can abbreviate property and addition. And it's addition clearly here. Next, a times 3 equals 3 times a. The placement of the numbers and the variables have switched. So this is the commutative property of multiplication. And then lastly, we have g plus 0 equals g. So we start out with g, add 0, and you end up with g still. So this is the identity property of addition. Now let's use the properties. Oftentimes we may memorize the properties but not really understand how they can help us with math. Let's try to see if we can figure out how these properties will help us. You want to buy a camera for $72 and a case for $18. Use mental math to find the cost. So in this case, what we're doing is thinking about the numbers 72 and 18. Rather than adding 72 and 18 immediately together by thinking about the tens and the ones place value, let's just think about the 8 and the 2. The 8 plus 2 creates another $10. So you could think about it as $70 plus $10 plus the 8 plus 2 is another $10. So here I've broken up the cost. I've changed it into tens, groups of tens. So from the $72, I'm thinking of it as the number 70. And the number $18, I'm thinking of just as $10. And then I'm now taking the ones, 8 plus 2, and creating another set of $10. So now it's easy to add mentally because you can just think 70 plus 10 is 80 plus another 10 is 90. So by changing the numbers into groups of 10, you can add them much quicker mentally. Use mental math to simplify each expression. All right, so here's where the properties are going to come into play. Notice that usually, according to order of operations, we would think that we would want to do the 13 times 4 first because that's inside the grouping symbol. However, what we've learned from the properties is that the order can switch. So what I'm going to do is 4 times 25 first. Remember that with multiplication, you can multiply out of order. 4 times 25 is an easy one to work with because 4 times 25 is 100. I could do that mentally. And then times 13. Well, you could just think 13 times 1 is 13 and then tack on the 2 zeros. 1,300. So by putting these numbers out of order, putting 4 with 25, I get 100, which is a very easy number to multiply with. And then times 13. 26 plus 25 plus 44. I'm going to add the 26 and the 44 first because the 6 plus the 4 will give me a set of 10. Then I'll have 20 from the first one and 40 from the last one. And now I have 70. And 70 plus 25 is easier because we have around 10 and then we're adding with the 25, which is 95. So by putting these numbers out of order, I'm able to add them faster without having to count the ones place values. Next, 5 times 7 times 20. I'm going to multiply the 5 with the 20 because that gives me a nice round 100. And then lastly, I'll multiply with 7, which is 700. So although I wrote out the work to demonstrate it to you, many of these problems with a little bit of practice could be done mentally based on the properties, which tell us that we can switch the numbers around so that they can create pairs and groups of tens that are easier to work with. 4.5 plus 9 plus 6.5. Right away, the 4.5 and the 6.5 stand out to me because the 5 plus 5 will give me a group of 10. So I'm going to add those first. This might be something that you could think about doing in your head. So we've created 11, a whole number. And 11 plus 9, once again, is a group, and that's going to be 20. So by taking the shortcut of switching the order, you could create a group of 10, or in this case, the ones place value, and add it with the ones, the 9, and create a nice even 20. 40 times 33 times 25. Well, the 33 would make it a little more difficult to multiply 25, so I'm going to multiply 25 times 40. And even within this, we can think of a shortcut. Instead of multiplying 25 times 40, I'm just going to think 25 times 4. 25 times 4 is 100, so I've used up those numbers, and left over is an extra 0. So I'm going to tack that on to the end, the extra 0. So now I've just done 25 times 40 very quickly. First make it 100 and then tack the extra 0 onto the end. So I did 25 times 4, which was 100, with the extra 0 made it 1,000. And now it's easy to multiply with 33 because you can say 33 times 1 is 33 with 3 extra zeros. You buy a sandwich for $1.95, a bottle of juice for $1.40, and an apple for 60 cents. How much do you spend? Well, I'm going to be thinking about pairs again. $1.40 and 60 cents. That gives me a total of $2, since 4 plus 6 is 10. Those would be pairs. And then $2 plus $1.95 is easy, since I have all zeros in the cents. That comes out to $3.95. 4 running clubs raised money in a 24-hour relay race. Club A ran 173 miles, Club B ran 154 miles, and Club C ran 107 miles, and lastly, Club D ran 156 miles. What was the total number of miles that all 4 clubs ran? So let's start with A, 173, B, 154, C, 107, and D, 156. Now looking in the ones column, I see a 3 and a 7, which makes a 10, and a 4 and a 6, which makes a 10. So I'm going to add 173 and 107 first, giving me 280. So I've taken care of these two numbers. Next, I'm going to add B and D, since they include pairs. 10. This gives me 11 and 3. And now it's going to be easy. 10 plus 80 is 90, and 3 plus 2 is 5. So you can also break up your tens when you're adding and break up your hundreds. So in a sense here, what we've done is added just all the ones, then gone and added all the tens, and then lastly gone and added the hundreds. By breaking that up mentally, we can keep track of the numbers easier and perform the operations faster. Thank you for watching Educator.com.